Hello everyone. Today we are starting with a new concept of Moore machine. In the previous videos I have told you there are two types of finite automata. The first type is finite automata with final states without output, and the second is finite automata without final states and output. In the second type, that is without final states and with output, there are two types of machines, Moore machine and Mealy machine. In that Moore machine we will study today. Okay, what is Moore machine? It is a machine with a finite number of states and for which output symbol at a given time depends only on the present state of the machine. Means it is a machine with a finite number of states, and for the output symbol, means in the machine we will get the output for the given time. It will only it will depend on the present state of the machine. In Moore machine, output symbol is associated with each states. Means like when we draw some states like q0, its output will be shown like this, a, or something like qb1 with the associated with the states. Okay, in Moore machine the length of the input sequence is n, then the output sequence is n plus 1. Now see, when we give the input to the Moore machine of length n, then it will give us the output of length n plus 1. How Moore machine is mathematically represented? It is mathematically represented using a 6 tuple size. Okay, it is m equals to q summation delta q naught. It is called finite set of states. It is called input alphabet. It is called output alphabet. It is called state function. It is called machine function. It is called as starting state. In this representation we represent the Moore machine. Okay, so based on it, let's solve an example. What is the question given here? Design a Moore machine to produce output A if input ends with 101, output B if input ends with 110, and output C otherwise over the input alphabet 0, 1. Now see what the question tells. We have to design a Moore machine to produce output A. Okay, this is capital A, to produce output A if the input ends with 101. Means if the input ends with 101, output is A. If the input ends with 110, then output B. If the input doesn't ends with any this means condition, then it is output C otherwise. Okay, based on it we will start solving. Now see our step 1. What in step 1, as same we have to write the theory of the Moore machine. As I explained you now, what you have to explain in the machine theory, you have to explain it is a machine with a finite number of states and for which output symbol at a given time depends only on the present state of the machine. We have to explain about the sequence of the output sequence also, that the input length of the input sequence is n, then the length of the output sequence is n plus 1. And again we have to explain one concept also, that is in Moore machine the output is associated with the states. Okay, and then you have to write this mathematical equation and you have to explain it is a finite set of states, it is input alphabet and on. Okay, this is our theory. Now step 2, same as logic. Okay, in logic it is input alphabet 0 1, and what is the output? Now see, this is output alphabet, so we will write here output alphabet A B C. Okay, in this will be output this, that's why it is output alphabet. Q, finite set of states in which I will take Q0 as our string ends with 0. Now see, Q1 string ends with 1, same Q10 string ends with 10. Okay, now see, Q101 string ends with 101, same Q11 I am taking as string ends with 11, Q110 string ends with 110. Now see why I have taken these states. We have to see for the input 101 and 110. See, it can get 0 also, that's what I'm saying, string ends with 0. Okay, now see, Q1 is required in this also, means this one and this one, that's why I taken this. Q10 is required in this, that's why I taken this state. Q101 is this, where for 101 input. Q11 is for 110 ka 11, and Q110 is our required state. Okay, now see our step 3 is our implementation. Since it is a machine, means Moore machine, in Moore machine we have to show the state transition table as well as machine function table also. So now see, two input 0 1 and the states Q0 Q1 Q10 Q101 Q11 Q110. In this there is no final state. Okay, there is starting state, so this is Q0 is our starting state. Okay, Q0 is our starting state, you have to mention here. Now see, our machine function Q0 Q1 Q10 Q101 Q11 Q110. Now see, it is our machine function. See, what I want, when it gets Q0, it is otherwise, means not 101 or 110, we will output C. When Q1, it is also not 101 or 110, we will output C. 10 is not completely 101, that's why we will output C. Yes, 101 is where it is said that 101, if 101 then output A, then we will give output A. 11, no, there is no 11. See, for 110 it is B, as it is given in the question. For 110 we will output B, for 101 we will output A, otherwise C, that's why there are C for the remaining this. Okay, first we will draw the transition diagram. Now see, Q0 is our starting state, Q0, As I told you, Q0 is C. I will give C with the state associated. If it receives 0, we don't have to do any transition. We are not doing any transition. 0 in the same. I want when it receives 1, it must change to state Q1. Q1. Okay. Now see, Q1 is a state with output C. I will put here. Now see, if it receives 1, what I will check? It is 110 or 101 or another combination. Okay. Now see, if it is 110, what I will do? I will 101. I will choose this 101. Okay. If it is 110, I will make one another branch 1, and then I will make 0. Okay. Now see, if it is 101, what will output? 101. It should be A. Then it should be A. It should be C. Now see, Q, when it is in the 1, it is going to Q1. Okay. When it receives 0, means it is making ending the string with Q10 or that Q10. If it 10, it is going to Q10. If it 101, it is going to Q101. Same 11 Q11 and Q110 Q110. 110 must be B, rest all C. Now see, 0-1 transition is done. Now for this 0-1 transition done, for this only one means transition of 1 is only done. If it receives 0, it becomes 100. We don't require any 100, means it will output C. That's why I will make this transition to C. Okay. Sorry, it is 0. I am making transition to Q0. When it will receive 0, what I will do? See, you can call this also 10101. Means 10101. Ending with 101. So 10101 means I want this. What I will do? I will make transition of 0 to here, and rest 1 I will make transition to here. Now see, 101. Now see, 10101. Okay. Now I am remaining with these two states. What I will do? If it receives 1, make transition on same state. Its 0 is completed. What I will do? If it receives 1, I will make transition on Q101. If it receives 0, I will make transition on Q0. Now why? Let's see. The string can come this also, 1 1 1 0 1. See, 1 1 1 0 1. Ending with 101, we are receiving the output A. Okay. Same. If the input is like 1 1 1 0 1 0, there is no ending with 110 or 101. Now see, 1 1 1 0 1 0. See, output is coming C, means otherwise. Okay. This input 1 1 1 0 1 0 coming otherwise. For this is our transition diagram. That's why I make the transition of 1 from this state to this, and 0 to 0 here. Okay. Now see, for input like 1 1 0 0, no 101, no 110 ending. Like see, 1 1 0. This should not come as output, na? That's why I'm making this transition to this here for this input. Based on this, we will fill the implementation table. If it receives 0, it is going to Q0, Q1, Q10, Q11. Same, Q10 receives 0, it is going to Q0, it is going to Q101, Q101, Q10, Q1011, Q11, Q11, 0, Q11, Q0, Q101. Now say I am giving a easy trick how to do this. See, Q0 is receiving 0, means it is like coming as 0 0, but we don't have any state with this 0 0. There is state with only 1 0, this Q0, that's why I am writing Q0 only. When Q01, there is not any state with Q01, that's why I am making only we have Q1, that's why making this Q1. Same, in the same states, same way I have done, you can cross verify this, it will come same. Like see, Q11, when Q11 receives 0, Q11 is what? String with 1 1. 1 1, it receives 0, it must go to 110. Now check in the transition diagram. Q11, where is Q11? Yes, when Q11 receives 0, it is going to Q110. In the same way, you can cross verify your answer. And the last, we have to solve an example to show the output. Okay, in this way you can solve an example, this Moore machine question.